In this web work problem, we're asked to use the polar coordinates to find the volume of a sphere of radius 2. What function in rectangular coordinates represents the top half of the sphere of radius 2? So to find my surface, or my function of x and y, I have to know what the surface equation is for a hemisphere. And that is z equals the square root of c minus x squared minus y squared. And your hemisphere can get bigger or smaller depending on your value of c. So in order to find what my c would be in this equation, I need to know what c will give me a hemisphere of a radius 2. And to do that, I'm going to set my z equal to 2, my x equal to 0, and my y equal to 0. So we get 2 equals the square root of c, or c equals 4. Putting that into the equation, we get z equals the square root of 4 minus x squared minus y squared. So there's the top half of our surface, and we can go ahead and put that in for this answer up here. And to visually verify this in the Calcplot 3D applet, we put in positive of that will give us the top half of our hemisphere, and then the negative square root of that will give us the bottom half of our hemisphere. And then just to verify that it does have a radius of 2, I have a vector of magnitude 2 starting at the origin, and it hits the outermost edge of the surface, and it does have a radius of 2. So now going back in, to define the limits of integration for the function of x and y, we're going from the bottom surface to the top surface. So we set our integral from negative square root of 4 minus x squared minus y squared to the square root of 4 minus x squared minus y squared of 1, since we're not trying to find mass or anything like that, we're just trying to find volume, dz. To find our next limits of integration, we need to find where the widest part of this surface meets at what value of z, or what z plane. For here, it's just equal to 0, because we can visually verify that here. We put in the top, and then we put in our z equals 0. It cuts it right in half. So that's the region that we're going to be integrate. That is the plane that we're going to be applying the limits of integration on for x and y plane. So it's not always going to be 0. In order to find out what plane it's going to be, you find some value for z, you set equal to something, and then you set it equal to both of those equations. And if those equations still agree by the time you're done simplifying them, then that's the plane that you're going to be integrating over. So to find the next part, we're just going to set, since we know it's going to be the plane of z equals 0, we're going to use the simplest function, and it's just going to be the positive square root of 4 minus x squared minus y squared. And then simplifying, we get y equals the square root of 4 minus x squared. And that's plus or minus. So we can see that here, this is the positive square root of 4 minus x squared. And here's the negative. And since this is the bottom, we go from the bottom to the top. It's going to be dy integrating from negative 4 square root of 4 minus x squared to positive 4 minus x squared. And then to find our limits of integration on our x, we go from the left to the right of our function of x, and we see that this encapsulates our function fully. So that's going to be from negative 2 to 2 dx. And now in order to convert this to polar coordinates, we're going to have to simplify this further. So we get dot dot dot, that's going to follow us along. Actually, I'll go ahead and put them in. 2 and then since this is just going to be a z from negative square root of 4 minus x squared minus y squared, and then to the positive 4 minus x squared minus y squared, and then dy dx come along for the ride, and then we get the integral negative 2 to 2 integral from negative 4 square root of 4 minus x squared square root of 4 minus x squared. Of simplifying that would get us 2 square root of 4 minus x squared minus y squared dy dx. And then to simplify this further, we just pull a negative out in order to convert to our polar coordinates, because this would equal our r squared. And so now converting to our polar coordinates, we get, since this is going around in a full circle, it's going from 0 to 2 pi, so theta is going from 0 to 2 pi. And our radius is already stated. It's going from 0 to 2. We can put in our polar coordinates. We have, do that in a different color, the integral from 0 to 2 pi, integral from 0 to 2 of 2 square root of 4 minus r squared r d theta. Don't ever forget to be a pirate when you're solving for these. That r can get away from you if you don't. And then from here, it's all just about integration, which I'm sure everybody's pretty comfortable with. We did the hardest part, which is defining the two surfaces to encapsulate our integration region. So I hope that you found this helpful. Here are the answers.